Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Aisyah Aulia Hussein. I am from Department Mathematics of Diponegoro University. I will thank you to the chance that given to me. Here I will present my paper. This paper has previously been presented in INSPINSA 2020. The title of this paper is Forecasting Model of COVID-19 Case Using Fuzzy Time Series Using Percentage Change as a Universe of Discourse. Okay, now let's get to the discussion. Introduction. The novel plague originating from Wuhan, China are spreading so fast in various parts of the world, and one of them is Indonesia, which has a very high increase in daily cases. Forecasting the case of COVID-19 can be a reference for increased preparedness and making decisions for the right solution of this pandemic in the future. And then let's talk about Fuzzy Time Series. Fuzzy Time Series is a method introduced by Song and Chisholm 1993, which is a concept used to predict problems in which actual data is formed in linguistic value. There are many methods proposed with case studies, namely enrollment of Alabama University. One of them is Meredith Stephenson and John A. Porter, using the percentage change from year to year as the universe of discourse and saw better result as of accuracy than previous existing methods, including the methods proposed by Jelene Burney and Ardil, and Song and Chisholm too. Okay, there are three definitions of the Fuzzy Time Series that are referred in this paper, namely regarding to the concept of fuzzy time series, fuzzy logical relationship, and fuzzy logical relationship group, fuzzy set, and triangular membership function. And now I will explain the method of fuzzy time series using percentage change. Step 1. Define the universe of discourse U by partitioning it into 7 intervals of equal length. There are U as universe from 1.8 until 3.8. And then the table consists of named interval and frequency of each interval. And then step 2, find the density-based distribution of the daily percentage change by sorting the data into the corresponding interval. Find the interval that has the largest number of data frequencies, the second largest and the third largest, then divide each interval into 4, 3, and 2 sub-intervals with equal length, respectively and sequentially. This step divides 7 intervals into 16 sub-intervals. Step 3. Define each fuzzy set xi based on the divided intervals and fuzzify the historical COVID-19 case, where fuzzy set xi denotes a linguistic value of the day-to-day percentage change represented by a fuzzy set. We use a triangular membership function to define the fuzzy set xi. The result shown in the next table. Okay, this is the data of the COVID-19 case taken from the National Compass website during June 2020. The table following by date, daily case, percentage change, and linguistic value of each data. Step 4. Build FLR or fuzzy logical relationship and FLRG fuzzy logical relationship group that will be used to change the value of the fuzzy rule becomes the value of the group's value. And there is the following definition of FLR. Step 5. Defuzzify the fuzzy data using the forecasting formula in the below. TJ is the forecast percentage change, and AI mean 1, AI plus 1 is the midpoint of the fuzzy interval xi mean 1, xi, and xi plus 1, respectively. And then the last step, step 6, examine and calculate the accuracy of fuzzy time series method to forecast daily COVID-19 case using percentage change as universe of discourse with MSA and AFER. Here the equation of MSA and AFER We use the FR value to know the criteria of the forecasting method. Here the table of the criteria, following by FR value and the criteria of each value. Then we get to the result in the form of table and graphic. The table shows the date, daily case percentage change day to day, forecast percentage, forecast case, and the difference between actual data and forecast. From that all, we get the MSA and AFR value. MSA value of 447.83 and AFR of 0.042514% is so very good result of the forecast method. And then the graphics show the comparison the actual data shown by blue line or blue point and the forecast data shown by red line or red point. The last but not least, the conclusion of this paper is forecast value sounds very close to the actual data so that it produces an excellent AFR value of 0.042514% and it means this forecasting model of COVID-19 can be categorized as very good. This excellent forecasting model using 40-time series can be used as an alternative model for predicting the number of COVID-19 cases in the future. Prediction with this model can be done using prediction methods such as a Markov chain so that it can be useful for making decisions and right policies during pandemic. And this is the references of this paper. This is the end of my presentation. Thank you for your attention and the opportunity that given to me. I hope it will be useful for me and for all of us. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.